Hello, welcome to the video presentation for NLPStatTest, which is a toolkit for comparing NLP system performance. Let's start off by introducing our motivations for developing NLPStatTest. First of all, it is very important to compare your system's performance, and the common technique is to use significance testing. However, previous studies have shown that significance testing has not been done properly. To properly run significance testing, one has to conduct exploratory data analysis to choose an appropriate test by assessing test assumptions. Most of the significance testing is based on the p-value approach, and the many factors are associated with p-values, such as sample size, effect size, etc. Also, significance testing based on the p-value approach alone is not sufficient because, first of all, statistical significance is not practical significance. Therefore, we need to go beyond statistical testing by estimating effect size and conducting paralysis. Lastly, we would like to provide a tool for NLP researchers to systematically compare system performance. So what's the problem with statistical significance, or namely p-values? That is, no matter how tiny the difference is, given a large enough data set, the p-value will always approach zero, yielding statistical significance. But the actual difference might not be scientifically meaningful. Practical significance measures the actual magnitude of an effect, whereas statistical significance tells whether such effect exists or not. We need both, and we can use effect size to estimate practical significance. For example, Cohen's d is the standardized means difference, and there are other ways to estimate effect size as well. Additionally, we need paralysis to compute the sample size for test corpus before a comparison. There are two kinds of paralysis we can do. Prospective paralysis is to determine the sample size when choosing a test corpus, and the retrospective paralysis is to show the achieved power and to estimate false negative rate. Then we propose a three-stage comparison procedure. First, building an NLP system, which is standard to NLP research. We start by identifying the NLP task and choosing an evaluation metric. Then, optionally, we can choose a test corpus by conducting pre-testing paralysis. Let me show you the pre-testing paralysis implemented in NLPStatTest. So this is the page for prospective paralysis. First, we can specify the parameters here. Let's choose a two-sided test, and the treatment difference is 0.1, and the standard deviation is 1, and the desired power level is 80%, and the alpha is 0.05. Let's run, and we have the results. So the required minimal sample for these set of parameters is 787. Then we can go to the second stage, which is the main comparison stage here. We have 4 sub-steps here. First one is data analysis, then testing. The third one is effect size. And the last one is post-part analysis. So this is a page corresponding to the main comparison stage. We can upload a data file, submit the file, and submit complete. And we go on to the data analysis step. So the first parameter is the evaluation unit size, which will be chosen here. So an evaluation unit is a set of test instances that constitutes a single value of evaluation metric. The second one is the metric to represent each evaluation unit. You can choose either mean or median, and we have the option to randomly reshuffle the sample before computing evaluation units. And we specify alpha here for testing normality. And last one is the error tolerance, which will help us to choose a good evaluation unit size. Let's just run this one. And we have the results. So the first part of the result is about choosing evaluation unit size. The red line here corresponds to the sequential differences, and the blue line is the standard deviation. So we want to choose an evaluation unit size at which the standard deviation is sort of stabilized. Here we can see at 21. After 21, the standard deviation is almost, the decrease in the standard deviation is almost like trivial. So we can then let the evaluation unit size be 21 and run again. Yeah, so here we can have the histograms, visualization histograms. So for first sample, second sample, and the differences. And here's the result. First one is the normality test, which here suggests that our data passes normality test, and skewness, which is used to check whether the distribution is symmetric. And last one, we recommend a test statistic based on these two. So here we recommend the mean. And here we have 3 lists of tests we would like to recommend or we don't recommend. So the first one is a recommended test. Here, because the sample is normal, we recommend a t-test. And here is the list of less recommended or less preferred tests, which might be appropriate, but not preferred due to various reasons. Let's go to the second step, which is significance testing. First, we choose our alternative hypothesis. We can do a two-sided test, and we choose the true difference between the two samples based on the test statistic we've chosen before. And then we choose the test, which is a student t-test recommended by our system, and we run this to obtain the results. Here is the confidence interval based on the mean, the p-value, and the decision to reject or not to reject H0. We can see we cannot reject the null hypothesis because the p-value is greater than the preset alpha. Let's go to the third step, which is effect size estimation. So first parameter is the alpha for computing the confidence interval, and we implement 4 effect size estimators. So the first 2 are applicable to the t-test, and the third one is an unbiased estimator for median, and the last one is for Wilcoxon sign rank test. So let's choose the first 2, and we have the estimates and the confidence interval. Then we can go to the last step, which is retrospective power analysis. So here, the first parameter of the set is the number of different sample sizes on the axis of the power curve, which here we denote it as the number of power measurements. And the second one is number of iterations at each sample size. And the method of power analysis here, because we know the sample is normal, we're going to use Monte Carlo simulation to directly simulate from normal distribution. And this is the alpha level for the Monte Carlo simulation, which we use the t-test to conduct the power analysis. So let's set the number of power measurements to 5 and the iteration to 500. And we can run. And we can see here is the power curve. So at the largest sample size, the power is still quite low because we know the null hypothesis is true and we cannot reject it. So we have like the very small power. Lastly, we can download the results by printing out the full report to a PDF. So here is just the pages of previous steps. And that's it for the main comparison stage. So the last step is reporting various results. Here are the list of recommended results we recommend reporting. So how to run NLPStatTest? We have 3 options. The first one is the web-based version, which is what I just showed here. And the second one is a local GUI, which can be downloaded from our repository. And the third one is to use command line to directly invoke the Python code we have. And this is the URL for our NLPStatTest toolkit. And that's it for our presentation. Thank you for your time.